Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about CNC laser tools. So let's dive right into it. Now first we have to understand just a brief overview. What the heck is a laser? Now laser is a very fine-tuned format of light. What does that mean? That simply means if you look at any screen, any LED, any light or whatever have you, it generally has a whole spectrum. Lot of frequency, lot of wavelengths. Now if you can fine tune it, meaning like, okay, we shall only produce one spectrum of it, one exactly as tight as possible, then you have very fine-tuned light, which is laser. And what's the core aspect of laser is that if you ever read at the details of lasers, they are not that powerful. Like you will be like, hey, this is like 102 watt CO2 laser. It's like, that does not sound a lot. You have 100 watt light bulbs, you had other equipment that consume 100 watt. Even if you go to industrial scale that can do this sort of thing, they're like, 2 kilowatt, 3 kilowatt, not that much. Heck, if you had a normal CNC router, that will consume more power than that. So what the hell is happening? Well, the core aspect of laser is that it can pack that much power in a very tiny spot. That's the critical aspect. And given the fact that it's very fine-tuned, scattering is almost negligible, specifically if you rightly select the material. So that creates a very powerful scenario. You can do a lot of things with laser. Most common thing is, oh, we're gonna cut with laser. Not necessarily. You can do amazing things. For example, paint stripping. Now you may like, who the hell needs paint stripping and in large enough scale where you need to build tools for it? Yeah, it's a big enough industry that people made tools for that. Rust removal, it's a very big thing in industrial environment. This is a handheld laser that you are using to remove rust. Yes, it's not removing paint, it's removing rust. And that's like, paint stripping, cleaning, welding. Again, you may think it can only cut. Again, it's depositing heat. If you are putting anything else there, it will melt it. So you can do welding, you can do cutting, you can also do engraving. So there are a lot of things that you can do with a laser system if you know how to use it. And CNC mounting, basically you can do almost all of this with your hand also, but it's not efficient. So if CNC mounting it, basically computer numeric control allows you to do automation, meaning you can do large batch of work. So that's the whole point of laser. So how do you create this laser that can do something like this, where I can cut steel, 2 mm steel here? Well, there are many possible sources. So do not freak out as like, oh, you did not cover this or that. It's like there are many possible sources, but you have to understand core aspect. Physics does not allow laser to be very efficient flat out, and realistically speaking you will be very lucky to get even 20%. Now what I'm counting here is power from taken from your plug and gone into your workpiece. Like again, if you take 1 kilowatt, a 1 kilowatt goes into your workpiece, GG. Realistically you will take 1 kilowatt, 100 watt might go to your workpiece. So you have to understand that. And if somebody is selling you this very powerful, or like CO2 lasers are very inefficient, fiber systems are around 4x powerful, be mindful that simply means this is very low efficient, not that this is closer to 100. It's very low efficiency, and it's based on quantum laws, so it cannot be tampered with, it cannot be worked around. There are some designs that are claiming achieving almost 40%, but that's super duper hyper best case scenario. So realistically, do not freak out if you even buy something very small power in terms of laser and you're like, dude, why the heck my energy bill went YOLO? That's the whole point. It's very inefficient. Now, what wavelength of laser you use? Because again, it's a spectrum. It can be anything. It can be microwave laser if you want to do it. It can be X-ray laser. Figure out the optics for it. You can do it. It's just like whatever you want to do with it. So workpiece defines the wavelength. Meaning, if you are dealing with woods, ceramics, or let's say thin materials, acrylic, plastic, cloth, in those sort of scenario, non-metallic objects, generally people prefer CO2 lasers. This is a common structure that you see. Now, why is that? Well, it creates infrared that is in thermal range, meaning 9.6 to 10.6 micron. Now that's the very critical aspect. This wavelength is very easy to reflect with gold. So if you have a mirror back there, and first surface mirror, meaning it cannot go through glass, it will damage the glass over time. It has to be first surface, meaning you ground your glass properly and then you just lay a gold layer to it, then it will reflect 100%. And that's why this laser, even though it can punch through very thick cardboard and all that, just even wood, why the heck it does not set that mirror on fire? That's the whole reason. Every atom has certain behavior, and majority of the atoms have some spectrum where it will like, though you shall not pass, like flat out. Every element, be it aluminum, be it silver, be it gold, has a spectrum where it's like, if you shine a laser exactly in that frequency, it will just bounce it back. It's like, bro, I don't care. I simply don't care. So that's the whole point. CO2 lasers are very, and again, generally you're not going to cut gold with it, so people are happy with it. It works really well with basically non-metallic objects. However, in metallic objects, it's really not that powerful. You can make it even ludicrously powerful, but it just does not have the coupling efficiency to warrant large scale use. But the moment you go to big boy fiber laser will have a seed laser diode, and then it will have pump diodes that will allow to ludicrously high pumping efficiency. And because the fibers can be coiled, even though you may see the box that are this small, it could have kilometers of fiber into it just by spooled up. That allows really high pumping efficiencies, meaning the coiled fiber section, it can literally take 3 watts input and amp output of around 1 kilowatt. That's the whole. Now again, you are pumping energy into the pump diodes also, so I'm saying the seed would be 3 watts and the output would be 1 kilowatt. So it has fish amount of power, meaning now this puppy is in near infrared, meaning it's 1 to 3 micron. At this point in time, steel cannot handle it. At this point, aluminum cannot handle it, meaning anytime you are dealing with any laser that's doing some serious damage, generally they are using fiber lasers, simply because it allows to be a bit more efficient. It's like 3 to 4 times more energy efficient, so energy from your plug is much lower compared to a CO2 system, and it works very efficient with metal system. So if you are talking about like wood cutting lasers, CO2, you're talking about anything else, tada, fiber systems. And be mindful, when I'm talking about fiber laser, does not mean it only comes into near infrared 1 to 3 micron. There could be other designs depending on specific environments. For example, let's say somebody says, hey, I need to cut diamonds. It may have a specific frequency which is efficient for it. Other frequencies might just bounce off, scatter, or worst case scenario, melt. So you have to select the source based on requirement. Like CO2 lasers are used in skins. I had a laser dental surgery with CO2 laser. So be mindful. Right tool for the right job. That's the source aspect of it. Now, how do you deliver the laser? You got the laser, okay? You made your laser. How do you deliver the laser? That's the whole point of CNC. Well, the fastest option is Galvo lasers. Now, Galvo lasers have very small working area, meaning even if you are familiar with laser cutting machines, you know for a fact that they're huge. They're big boys. Now, the Galvo is very small. Like, you will be lucky to get even a A4 sheet kind of scale, like 200 mm by 200 mm, very small. However, it's idiotically fast, meaning it's super fast. Now, why it's fast? Physics, inertia, mass. It only has to move, basically light is fixed, it only has to move mirror, and it has to move it very little. So it can do it ludicrously precise. I'm talking so fast that this may look sped up, but it is normal time. And not to mention, it's kind of slow. And I only use this GIF because it's like slow enough that you can see it. In real time, some lasers are so fast that it's like whoosh. That's how fast it could be done. So it's ludicrously fast. Now, that only gives you control in 2 axes, meaning if you have a mirror that is moving in 1 axis like this, one in like this, that gives you X and Y. How about you control the depth? Because if you do not control the depth, the focusing will be off, meaning laser goes to a focusing point and then it spreads out. If it's spread out, it's not going to do anything. So you need that focusing system. Now, focusing system, it's very expensive given the fact that it has to either deal with laser when it's not very concentrated, or be made out of something that can let laser light pass through it without damage. Again, it's possible, that's why we have it. It's just expensive. Mirrors are surprisingly easy. Comparatively speaking, mirrors are much easier than lens system. Now, you can do 3D engraving with this, meaning, for example, let's say you are a tool manufacturer. You are making amazingly, idiotically expensive tools. You have to mark it. Now, if it's a precision ground equipment, you're not going to go like tang, punch mark on it. You can't use printers. Again, those ink will not last long. So you utilize laser engraving. Now, engraving aspect of it, you have to understand, it has to be done in 3 dimensions, because again, surface level will not be exactly the same, and most of the time it will be in curved surface. So there is a calculation algorithm that is moving the Galvo servers and lens autofocus constantly, so you get a proper etching. Now, these things are very fast, and this is the core of metal 3D printing. Anytime you hear about metal 3D printing, something like this, generally is using Galvo server systems. Now, it is not for high power application, meaning while a mirror can in principle reflect a very high power system, good luck finding a lens that will not go poof if you try to send 40 kilowatts up through it. Again, you can find it, but at that point, like, this and that, and then, and not to mention laser, even though you can in principle reflect light very far, the focusing atmosphere, then you may end up requiring a scenario where you have to pull vacuum for it. So is generally suited for low power application, but very fast, meaning in factories environment where they are using this for engraving, they'll have a conveyor belt, a system on top of it, done. And many people use this for business running, meaning now you're like, why the heck you will use something that has this small area? Many times you may think, okay, I'm, let's say, running a business of keychain engraving, and then you're like, okay, I'm gonna, why should I buy this? Because this can only process 1 object at a time, while I can buy a big laser system that can process, let's say, 8 or 12 of that. Here's the 12 of that will take much longer. This one quick, done, go home. These are very fast. If customer comes in, it's like, hey, I want this design, you take the file. How long it takes you to process the file, that's up to you. But after the file is processed, after the file has been sent to the CNC, this puppy is just like, done, go home, sweet dreams, done. So speed matters. In those sort of scenario, this is the only way. So Galvo servers are generally preferred for fast application where you need speed, you need very fast. Then we go to the most common system, CNC Gantry system. Basically anything that you see is just CNC Gantry. Now this is the most common type of tool. I'm reasonably sure even if you have dealt with 3D printers or normal CNC writer, that's what we are talking about. It allows for very large work areas. Now, laser can be spot or remote. Now, spot lasers are generally very low power lasers. You're talking about like 10 watt, 30 watt, 50 watts. Maximum I have seen 50 watts generally, and I'm pretty sure that was overrated. So again, it's light enough, it does not justify the cost of having a laser tube here, then bouncing it through mirrors. But again, it becomes necessary the moment you start to touch 100 watt because the laser will be this big. CO2 lasers are this big. At that point in time, you have to have mirrors that are reflecting everything, like this system. It is having mirrors, it's reflecting light there. Now, it does allow very large work area. So you can have like multiple meters of working area. So that's an awesome thing aspect of it. Now, how do you reflect laser? Well, again, a normal thing is using mirrors. Now, mirrors have this consequence that they are exposed to the element, quote unquote. Now, even if you have a sealed environment here, you have to understand you are literally vaporizing things. So there could be actual steam there. Now, steam not as in like a water steam. Steam could be other things also, other fuming gases also, which will destroy your mirrors. And that's why like whenever you buy any branded laser system, they will have a requirement of air filtration system because it will suck the air in, and because it has so much fumes into it, it requires filtration, then only it will exhaust it out into the atmosphere. And again, this is literally melting metal, so you will have metal vapor that could be deposited somewhere else. So mirrors are generally the perfect surface for that. You do not want that. So mirrors are good for low requirements. The moment you are talking about like some seriously high power equipments like this, where you are making love to 20 millimeter carbon steel, and I've seen this one China's demo that they are showing 100 millimeter, like 10 centimeter thick steel sheet. They're just like, lol, that was powerful. And to give you a context on that, what kind of steel, that's thicker steel than you see in JCB, so basically crane and bulldozers. That was thicker steel than that. Laser cutter was just like, you give a metal sheet of that caliber there, and just take it out, tack weld it, done, go home, sweet dreams. So these things can be ludicrously powerful if you want to. And scale, basically how small you can buy or how big you can make it, it's industrial class, meaning you can buy things that can process multi-ton metal sheets to something that's just gonna work on paper. So CNC Gantry is a very common system. Spots are generally used for hobby level, remote mirror systems are used for non-metallic objects, and fiber is used for whenever you have to make love to metal. So this is the CNC Gantry. This is the most common and popular aspect of it. Then we come to the rare puppy, that is robotic arm design. Now, this system is only used for mass production. So you will rarely find any video about it. You will rarely find people talking about it. It's very rare because it's only made for production environment. And it has only one job, that it can work with non-flat workpiece, meaning majority of the laser systems assume that your workplace is flat. Even galvanic system, even though it's working in a like quote unquote curvature, the lens is, flattening the image, quote unquote. So it's like literally X and Y. That's it. All laser systems are X and Y. This system allows you to work on, let's say, car chassis. Let's say your car chassis is complete half built and now you have to weld something to it. Again, you can utilize laser there. Like ABB makes a lot of laser. And again, somebody smart enough figured out how to make a laser engraver. Again, this is a toy kind of scenario, but you get the point. Like if you are dealing with something that has too much curves, too much physical movement requirement, rather than, well, inherently you can't have a laser that's gonna bend, but you can make bend the source, so you can have a laser that's bending. Now again, it's a fiber laser, you are just bending it and working on it. Allows for non-flat worksheet, and it can do a lot of jobs. So exactly how lasers have multiple application, be it paint stripper, be it surface cleaner, be it welder, be it cutter, whatever have you, same can be done with robotic system. Again, your supplier will define, like, can your fiber laser actually go up to that level where it can, rather than welding, it can do melting. That's up to you. And again, there are a lot of options where like all of these machines can come into 3-to-1 setup, where it's just like one tool head, but it has 3 options. So it's only meant for large scale enterprise scenario. It's not something that you and I are gonna see. So gantry system is very common. I have seen many Indian businesses have bought into this sort of system and they're printing money with this. That's a common system. But the moment you talk about like robotic system, that's only like Tata, Mahindra, these sort of companies can afford to touch it. And not to mention they are kind of new, simply because back in the days we are used to roboticize TIG welding, MIG welding, this sort of thing, and we became good with it. It's like, yeah, we have been working for like 40-50 years with this, so it's we good with it. But when you come to new systems, for example laser systems, company have to take a risk, because again, if you know how something works, you're like, hey, I'm comfortable with it, I know how this works, what is the defects into it, like I know laser does require a bit of a new approach, where it's like, okay, we are using laser welding, let's see. Now it does have the benefit, it does cost a lot, but it does have speed, meaning if you are welding one chassis per hour, you can weld one chassis per 15 minutes. That's how fast these things can go. So it does have the benefit, again, higher capital investment, and I'm reasonably sure even higher power consumption. But if speed is the critical aspect for your production, buy this. So robotic arm is the last CNC option that generally, if you are really lucky, you get to see. That was my presentation on CNC lasers. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.